No problem, that's good. Anyone having any problem during the installation of the software? I haven't upload. I will upload to the classroom. Not to say upload. I will share the link to you all. Then you can yeah. I mean get the recording from the link. But I haven't done. I haven't done it yet. So give me some time. Okay. But the thing is, actually, I not really prefer you all uh to get the recording because you should spend time to join the class now and then don't spend another time to go through the recording again. Okay, so you should spend more time in doing your questions. Okay, I think still have few students not joining yet. Okay, maybe we give another 3 minutes. How many lab? So we have 5 experiments of experiment 1, 2, 3, 4, 5. So we have 3 sessions of the lab. So normally I will settle in first the 2 sessions, week 2 and 6. Then week 10 is your lab report submission. And lab Wk2. So means I will ask some questions based on your report. Then you need to answer some questions. Are you okay? So today we are going to do experiment 1, 2, 3. You can see my screen, right? So basically everybody here. Quite many not. I think a few students not coming joining yet. So this morning you already watch a recorded video for lecture 3, right? If you that's good. So if you have any susah, if you have any, don't worry, no worry, no worry. Okay, we introductions only. So after that, we still will go through it and then we discuss the tutorial questions and everything. Okay. Mm. Mm. Yeah, it's quite normal if you feel difficult at the beginning. Yeah, tutorial 2 is quite hard, but it's actually very normal. Every time when the students start the tutorial, then you feel tutorial 2 is hard. Then eventually we discuss some questions. Then you think, oh, tutorial 2 okay already. Now then you go to tutorial 3, you will feel tutorial 3 harder. Then tutorial 4 you feel harder. But then yeah, that's the thing. That is the thing. So that's why you all cannot refer to my answer. You need to do it yourself. Okay? You have to do it yourself in order to tune your principle and your own rules, okay, so that you follow exactly what is the correct way. If you yes, it's very normal that you need to spend a lot of time to do one small question. Yeah, but the thing is you have to It's like mathematics. You have to do it yourself, and then you need to keep practicing in order to be improve your in order to improve yourself. Okay, what I mean? So if you refer to my answer, you refer to my steps at the end, when you go to the you see for the examinations or your test, you are not able to answer the questions. Understand? So you have to your question. I didn't receive anything. Oh, why You you send the questions to the to the classroom, the form, is it? Oh yes, I have one turn in, but then the thing is I didn't receive the notification. How come? But your turn in is your turn in is without any document or going. I can only see, maybe I show you. I can only see turn in without any document. So that's why I prefer you all. Maybe you try to submit here. Submit to this Google form, and then you add out. Understand? You don't submit in classroom. You submit inside the classroom, the Google form here. You submit to Google form or classroom. If you submit to the form, maybe I click the form. Okay. Then oh for people respond lah. Okay. Uh oh, here. Okay. That means no notification. Never mind. It's here already. So I think it's my mistake. It's my problem here. No notification. Maybe I need to set something. Okay, I didn't receive any notifications. I'm not aware about this. Uh, okay, but yeah, you all can leave a message if you submit something. Then you may leave a message in the comment or private message or comment box in the tutorial submission. Okay. So it's okay. I will check about it. I mean, I will check about check your work later. Okay. Okay, then we will do the. I will. Okay. Yes, if you don't want to know, mean who are the one who asked the questions, then I won't really tell. But sometimes I will extract your questions and then discuss in the class. Okay. Any other question or problem? It's actually very normal, but then I want to tell you, you need to keep trying to do the questions. Don't say, yeah, I spent 1 hour to do, waste my time, then I don't want to do. But if you want to give up, then most probably you can't improve. Okay. Then you say, I wait for me to do first, then later on only I refer her answer. Actually, it's not like that. Okay. You can refer to my answer, of course, but the thing is, you actually won't learn a lot of things. And at the end, when you go to the exam or test, then you don't know which is the correct way and why your method cannot work, you don't know. So that's why you need to keep trying with your method, and then you can check and see why you can't get the answer. And at the end, you improve yourself. Then you when you sit for the exam or test, then only you can get higher mark. And get what I mean? So it's like mathematics. Okay? Last time also your teachers always tells you, right? You need to do a lot of practice. So you need to do a lot of questions, mathematical questions. So because it's not something that you can memorize and then you can sit for the exam like the also essay questions like, oh, you remember this sentence, then later on you rewrite it, then it will be the very beautiful sentence. It's not like that. Okay. So unless I come out with exactly similar question that you can copy exactly, but of course it won't really happen. So every analysis questions that it's out in the exam is a new questions that that I don't think you will see it anywhere because I will try to adjust. I mean, edit the questions, edit the circuits. So that's why you need to do your own. You need to have your own analysis mindset. Okay, how to do the analysis, your own analysis way. Okay. Okay. Then we should go to the lab. Now, okay, so any questions you can post to the classroom, yeah, the Google form, then I will answer. Okay, and then please notify me, okay, you can send a message to me, okay? Okay, okay, piece 5. So for this lab, actually is about you need to know about the basic about resistive circuits, then Ohm's law, node analysis, maximum power transfer, Thevenin operation, and no need. This is not important. Okay. This is not important. And then piece 5 version 16.3 and above, then pen drive is not really need. So this is a bit about the history about piece 5. So it's actually used to do the numerical analysis for electric circuits. Then at first is developed by microsim. Then later on it is called schematic, and then it's bought by Wk2. Then later on they rename the schematics to capture. Okay, so it's a bit about this history. It's not very important. So what can PSPI do? PSPI can actually do the DC analysis, transient AC analysis, Fourier noise sensitivity, distortion analysis, or modern color analysis. But mainly we will talk about DC, transient AC analysis, and Fourier analysis in our lab. Okay, so look at experiment 1. Everybody okay, right? The installer. So you are having your software with you, right? Installed software. Yeah, PSPI light is okay. Okay, that's good. So now, first experiment is about writing a simple netlist circuit description. So what's the netlist description in? Okay, netlist circuit description means it is like a programming, something like this, that you write a program to describe your circuits. It's exactly like programming, but of course, like C programming has its own syntax and its own rules, right? So same to PSPI, it also has its own rules that you have to follow. So we go to here first. So netlist is a description of circuits that is typed in an ASCII text file, and then it will interpreted by the SPI. So some rules that you need to know, it is not case sensitive. So which means R1 and capital R and small letter r are the same element. Then some scale factor you have to follow here. If you want to be have nano, that means you need to put N. Micro, you need to put a U. Okay, milli, you need to put an M. Mega, you need to put an EG, something like this. Okay, can I ask why mega cannot put M? Capital M. Yes, I want to check whether you are listening to what I just mentioned or not. Yeah, my pen cannot function here. Okay, so because it is not case sensitive, so if you put a capital M or small letter m is actually the same. Okay, so that's why your mega need to put MEG. Then you can use it. You want to ask me, I don't want to put MEG, I want to put MEGA, can or not? Cannot. It will only interpret MEG. They say MEG stand for mega means they will detect MEG as mega. Understand? You cannot say I don't want MEG, I put MG, can or not? Cannot. It's not up to you to define. You need to write something that it can be understood by the software. Okay, so then the title line. So line 0 is in the netlist is a title line. That means title line is mandatory. So means you should not start your circuit description in the first line. So for example here, okay, first line 0 will be title line. So if your VS start from this title line, VS, that means that they will skip this VS, means you are not having VS at all. Understand? Means if your VS you put up on line 0, that means your circuits is not having a voltage source. So that's why this is a rules that you need to follow. Line 0 is for title, so you don't write any important thing in line 0. Are you okay? Then so for how to describe the voltage and current source. So for voltage and current source, there has syntax for independent source, name, not one, not two, type, and value. So the name voltage source must begin with V. Don't ask me why V. Can I have don't ask me. I can have E. Can I have H? Can I have Z? As again it is like why your name is your name. Okay, so they say must have V, that means must have V. Okay, you type V, then they know, oh, it is a voltage source. So for example here, they write Vs. So then if you say okay, means I want to write Vs. I don't want Vs, I want V1, cannot? Can. You want V1, can, no problem. As long as you start with your V, then it will interpret it as a voltage source. Is that clear? Then if how about current? Current must begin with I. Then the voltage source, not one and not two, will represent the positive and negative terminal. Okay, so where's your positive terminal? Where's your negative terminal? So for example, plus minus here, then this is your V. Okay, so if your positive terminal link to number 1 and negative terminal link to 0, it means, for example, V1, positive terminal will be 1, 0, type DC, values of maybe 5 volt, then you write 5. Is it okay? So how about the numbering? The numbering actually is a thing that you need to fix yourself. You need to fix this numbering yourself. For example, you say the one you don't want to put here, you want to put here also can. 2 you want to put here also can. So for every branch, this is considered same path than parallel path, so you put 2, no need to put 3 here. Okay, so you the ground must put 0. Are you okay? So the number you have to put yourself. So if this is a new circuits, this is examples in lab, right? So that's why I already put the number for you. So if it is a circuits, a normal circuits, then you have to put number yourself. Then you need to check if your positive terminal for your voltage source is linked to number 1, then you put 1 here. Not 2 will be 0, then you put 0 here. Okay, negative terminal, positive terminal, negative terminal. Then the type can be DC, AC, or transient. Then the value. Okay, any problem? So the value, how about the unit watt? This watt, unit you want to put or not, it doesn't matter. Okay, you can put 5V. Are you okay? Can be entered without units. Okay, but the prefix, the milli you have to put because 1 M and 1 milliamp is different. Can you get what I mean? 1 M and 1 milliamp is different. This prefix, milli, mega, kilo, those things you have to put. Okay. Do not enter a space between the value and the factor when, okay. So means you have to put milliamp without space. This is okay. So milliamp, a space in between is not okay. It's incorrect. Sorry, I can't use my pen to write on this, another screen. So that's why the writing is a bit difficult to control. Okay, it's a bit not nice. Are you okay? Can see, right? Yeah. So resistors, capacitor, and inductor. So all of these 3 components is considered without polarity. No polarity. So name for resistor R, capacitor C, inductor L. Okay. Then node 1 and node 2 are the nodes that is connected to. So this doesn't matter how it connect. Okay. So it's considered no polarity. This one is extra line, wrong place already. This one can delete. By the way, I think I forgot to mention current. Current. So for current source, the current will flow from node 1 to node 2. So if your current is like this, current source, difficult to write. Okay, 0 and 1. So your flow from 0 to 1. So you're not 1 here will 0, here will be 1. And you understand? Then ground, as I said, the ground must be number 0. Then the .n statement is like your programming. .n means you finish everything at the end of the program. Okay. Are you okay? Okay, before we start the programming, I give you a few minutes. Can you try to calculate calculator? Use your calculator to calculate what are the not voltages here. Okay, 5 minutes consider. Okay, right. So the example in this lab is about write a netlist program to observe the not voltages. So can you tell me what is V1? What is V2? Can you tell me what is V1 and V2? Okay, can you calculate now? Use your calculator, not using the software. Use your calculator. Okay, I give you 5 minutes. Okay, 20 and 8. 20? What 20? 28, yes. V1 is 28. V1 should be 28, because it is linked to this voltage source, right? Then V1 28. V2 is V2. 1, 2. Oh, no, 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 1, 2. Not voltage is here. Not 1 and not 2. Then V2 will be 8 volt. Right, so this is your answer, right? Okay, then we are going to use the software to test whether we can get this answer or not. Okay, so let us run the software now. Let's do it together. So if you can't follow, then you let me know. Yeah. Okay, so we go to the program. So you open your program cadence and then search for a P580, like click. Then you should have something like this pop up. Are you doing together? Okay, do it together. Okay, I can't monitor you, but I hope that you are doing together. Okay, and no problem, I can wait. Ryan, okay, ready? Then we go to File, New, Text File. File, New, Text File. Then you open. Okay. Then basically you need to type this. Okay, this one is not typed for fun, so you need to understand how it works. So why VS? So VS 1 0, why 1 0? Because positive terminal is linked to 1, then negative terminal linked to 0. So 1 0, DC 28, DC 28. So R1, R2, R3. Why R1 equals to R1 is linked to 1, 2, then 10K. So that's why R1, 1, 2, 10K. So you try to type it out. Okay, not to type it out, you write it yourself. Okay, then end it, then dot end statement to end it. So basically, cannot copy. Okay, basically, okay, you spend maybe a few minutes to do it. Then I will show you my answer. Something like this, you should have. Any problem? Anyone can't follow? Can 90 need to type out. Need to type out, of course. This software text-based only. No. This software, experiment 1 and 2 will be text-based, then experiment 3 will be the register those drawings. Yes, that 90 you want to type anything also can. So you want to type experiment 1, or you want to type your name, you don't want to write all this also can, no problem. 90 is just title only. Can you understand or not? Course rep, Song Jian, please help to Song Jian, are you here?
Yes.
I want you to help to give me a slot there, so I can do the replacement class for Tuesday classes. Or the replacement slot is actually because our Tuesday is actually a offline class, so the replacement you can put it like evening class, maybe like Monday 5 to 6. If I'm not sure, I think you are available, right? Monday after my circuit, and this is if you are okay, give me your available time slot. Do you get what I mean?
Means I find an empty slot for that 1 hour lecture.
Yes, but it don't need to be that worry because that is a offline class. Understand? So you don't say, yeah, Monday already very packed, then still want to have replacement class. I don't want to use the word Tommy. Okay, like what Brian said is correct, just that I don't want to mention that name. That word. It's an offline class. Sunday, I don't want to put Sunday lah. I think Monday 5 to 6 should be fine lah. 3 to 5 is my second analysis, right? Then we put it 5 to 6. No, you have class. You got class. 5 to 6 you have class. Okay. So then Song Jian help me to settle one slot that you are free. Because our Tuesday we have three sessions. Tuesday public holiday. So I need to 5 to 6 no man. 5 to 6 can. No class. 5 to 6 free. If 5 to 6 free, Monday 5 to 6 free, then I apply the 5 to 6 as your replacement class. Okay, replacement. Okay, so it's not a dummy class, it's a replacement class. Okay, so okay, that's good. Okay, back to our lab. What is your problem? Do you have any problem? Last line before n must space one time. This one. If you want to put, I don't think it is a problem. If you want to put a space, it's okay. I think. Okay, then after you've done this, done right, then okay, replacement class. Okay, no, it's very sensitive words to avoid. We have no, you are. I think you are okay. To avoid that, I caught in trouble. Okay, so then next we have to go to save the file. So you have to go to file, then save file. Okay, then they will ask you where you want to save. So you find a place to save it. Then you can type whatever thing that you want. For example, experiment 1. Okay, but one small thing is you need to put .cir. Then here you need to select the .cir file. Get what I mean? Do you get what I mean? I create a new folder first. That for soon. Okay, you need to put .cir and then select here .cir. Okay. Why I say must, because if you are not doing this later on you may have an error. Okay, then save it. Are you okay? After you save it, and basically it's okay, but the thing is when you want to, we should run it already then, but when you want to run it, a simulation run, you can't click. It's a gray out, right? It's gray color like this that you can't click, is it? So what you need to do is you need to close the file only, not the software. Just close the file. Save anywhere you like. That you know where you save it, then later you need to retrieve it. So you save it, then you close the file only, then you file open. Then here, just now I save here, right? Then I will select the .cir file. This is the file that I saved just now. I open it back. Okay, it pop up again. Then now simulation run. Now you can click already. And seriously, you don't ask me why. Okay, I think this is the bugs in this software. So you need to close it one time, then only open. But next second round, then okay already. Only first time. You need to close first, then only you open again. Your file type no.cir file means just now you didn't save as .cir file. When you save it, do you save? That's why I say must. Just now when you save, then you need to type .cir. Then you need to select the file type .cir. 人件. Do you get what I mean? When you save it, do you save like this? Then click save. 人件, are you here? Trying. Okay. So save. If you are not saving like this, then you resave again. Save one more time. Then close the file. Then open back. What happened after run? Then okay. First of all, if you run successfully, okay. One more round. Run. Can you see here? You show something. Can you will see here? Simulation complete. Can you see simulation complete? That means no problem. So if you have, for example, if I delete something, then I run it. Because, then you say you are going to have something like this, missing not one, or here, you see it? Error, missing model. So means you have problem. You have error. Then you need to go back here. This one, how many? 5K. Okay, then you run again. Yeah, so simulation complete is one successful step. Then where do you view the output file? View the result. So you go to view here, view output file, view output file. Then scroll down. Can you see? Not one is 28 watt. Not two is 8 watt. That is tally with what you calculated just now, 28 watt. This is the result. Are you okay? Are you what? Can use this to double check answer during Wednesday. Yes, but unfortunately you don't have such time to draw the circuit out. If you want to draw the circuits out and then you want to run it, nothing happened. Brian, okay? Where's my problem? Where's the problem already? So Renjian, are you okay? The software so susah. I think it's very easy to use. Brian said, I press run, nothing happened. What do you want to happen? Now okay already. Renjian said cannot. Why? So if you have missing not error means something missing. So you check again. Is it you have missing maybe DC you forgot to type, maybe 5. I think you put like this. I think if you put like this also cannot. Okay, so you cannot put a space in between, or you forgot the .n statement. .n not n. You need to have a dot in front of the n. Small until I can't see anything happen. What do you mean by small? Brian means can you see the screen? Your small means you can't see the screen, or your word very small. Why cannot simulate? You can't simulate because first time you need to close it first. You need to close the file. Close the file. Close the file. Okay, then file open. Search back the .cl file. Yeah. Then only you can click simulation run. Why the screen word is very small? I also don't know. But the problem is actually I can't. I don't think I can. I zoom here also cannot. Last time also I planned to make it bigger, also cannot. So you can refer to the notes, because I mean the lab manual. Okay, the lab manual actually have all the steps already. Actually, I also have the recording for all these lab steps in Google Classroom. Okay, so if you can't follow, you can refer back to the recorded video. Okay, already. Okay, make a quick check. Anybody can't get the answer? If you can't get the answer, no sound. Oh, I purposely don't want to put the sound. Why need to have the sound? Seriously, I purposely don't want to record with sound because troublesome. It's very troublesome because yeah, I don't know why already. I think because quick one, so I just want to show where to click. So if it's synchronous with my sound, then may not be that good, and I need to record many times. Okay, so the video is just to show you where to click. Okay, then where are we? Okay, then you go to view, output, file, then you scroll down, then you get the answer. And you do it. Okay, a quick survey can. Okay, anyone, if can do, you type 1. Cannot, then you type 2. Can 1, cannot 2. We need to write lab report for this. No, your lab report will be another lab assignment that is related to what you have learned. Not this lah. This is so easy. I give you this as a lab as a report. It really underestimate your ability, right? Hey, why I only have a few students reply? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on roughly lah. Okay, so everybody want, that means no problem. Okay, no problem, then we go to lab 2. Someone settled already? Okay, settled already. Okay, this one. Before we continue with the software, so I would like you to same like just now, theoretical calculation. Can you calculate to me what is the terminal voltage and not currents at the terminal here, AB? Can you try to do it now? I give you 5 minutes like that. Okay, you try to calculate. Kelvin, are you here? Kelvin. I saw all the other repeat students are having the same slot as you, is it? Do you know about this? Oh, okay. Please remind me. How many people? I also don't know how many people. I think include you should be 3, not 2. I think 3. The other guy actually didn't really contact me. No, I think 2 or 3. I have to ask the other one. Okay. I think should be same batch because they asked their course rep to settle this registration, and the course rep reply no say got 2 students. And say 2 students want to repeat the subject. So I think should be same batch. Okay, but please remind me if I forgot to generate the attendance code, right? Because I may forgot. Okay, thanks. Okay, I will go to washroom a while. Okay, so you continue with your this calculation. Find the terminal voltage and Norton current. Okay, give me 5 minutes. Yeah, can do it. What is your answer? Terminal voltage and Norton current. 12.5 is correct. 12.5 is correct. I think so. I can't remember actually. We can check here. Eh, answer. I don't have any answer here. Okay, then. Okay, we need to do it. Mm. 1 minute. Why I can't write? I'm writing that stuff from here. Wait, never mind. Okay, here. So in order to find what is VAB, VAB is your Thevenin voltage. So you need to use VA minus VB. Okay. How to get VA and VB? So VA is basically here. Is this side, yeah. So this side you have 75 watt, 10K and 5K. So you have to use a voltage dividers rule in order to get VA. So basically VA will be equals to what? Voltage divider rule. So is 5. Oh yeah, I'm using my mouse, right? 5 over 5 plus 10 is 15, right? 15 times with 675. Okay, so basically you get, I think, 25, is it? Then VP, so because it is open circuit, so this 10K no need to consider. So you can use again voltage dividers rule to settle here VB here at this point VB. So will be what voltage dividers rule 25 25 25 means divided into 2 25 25, right? So 25 divided by 2, so you get around 12.5. So you use VA minus VB, then you get VAB. So you get around 12.5 watt. Is it? Can you get it? Then Norton current. So in order to find Norton current, actually we find the RTH. Thevenin resistance. How to find Thevenin resistance? So you need to short here and here. Then your eye need to look inside here. Okay, so you have these two in parallel, then series with 15, and then series with 10K. What is the value you get here? You're all with me? Why what? Huh? Oh, why means yes. Okay. Ziyuan say what, Captain? What is the answer? RTH? Yeah, roughly around 40.83. 83K. So can you get okay, Oma? Then can you find Norton? I Norton will be equals to I equals to cannot write. I can only write here. V uh, VAB voltage divided by RTH. How much you got? Something milli, yeah, 0.306. I can't remember, but when you show me some answer like this, then I can recall. Yes, 0.306 million. Okay, 0.306 milliamp or 0.306 M, yeah? I think should be milliamp, because we have the K. Okay, milliamp. Okay, that's good. So your calculation part is settled already. Then now we go to the netlist description. So how are you going to write the netlist? Why is it so long? There is a reason, yeah. First of all, because it is in between of AB and it is open. In only superposition. VA and VB, VA is VA and VB. Superposition? Why do we need superposition? A and B, I don't understand why I need to have superposition. No need superposition. You want to use superposition way to find AB can also, but the thing is because of AB for terminal voltage it is open circuit. So when you really open, so means it's not a complete circuit. Understand? So you need to find VA minus VB in order to find VAB. Means separate the circuits into two parts. Part 1 here, part 2 here. Aileen, can you get what I mean? I don't think you can use superposition because it's not a complete circuit, because it's already open here. R6, this R6 will not affect, R6 will not affect, yes, but yes, that's why it's open circuit, so R6 no need to consider. So we only consider these two voltage dividers rule and then these two voltage dividers rule. R6 and R2 we need to ignore. Are you okay? Okay, then we continue, yeah. Where are we? Okay, so the problem now is PSpice cannot have open circuit like this. Understand? If open circuit like this, when you run it, then PSpice will say, your circuit is open, you cannot run, there's an error. So what we need to do is, we need to put something in between AB. You need to put something in between AB. So what is the something? Yes, you need to short or open it. So how we know that whether it's short or open it? We took care. So for Thervenin, right, it is an open circuit voltage source. So in the open circuits. So for Norton, it is a short circuit. So in order to determine a Norton or equivalent, then you need to find open voltage. Yeah, your experiment can close already. So any other question? Okay. So your open circuit voltage for Thervenin VTH, yeah? This is open circuit. Open. For Norton, I Norton, it is a short circuit. Okay? Can you get it? So how are you going to put to represent this open and short? So you have two method. Method one, you can use resistor. So for open circuit voltage, then in between of terminal AB, you can put a resistor with very high impedance. So you can put, for example, 100 mega ohm for in between AB, okay, so that it is to find VTH, Thervenin voltage. So if it is a short circuit, then you put a very low impedance. Understand? So you can put, for example, 1 ohm to represent short circuit. This is method 1. Then you have method 2. So our experiment using method 2. Method 2, capacitor will be open circuit and inductor will be short circuit. So that's why the questions here, they put capacitor and inductor. Are you okay? And the value of capacitor and inductor is not important. You want to put 1K, 1 or 1 M or 100 also can. The value of capacitor and inductor is not important. So you can put any value, but you need to put 2, 3 here, 2, 3 here, capacitor or inductor. So for this experiment, we need to run 2 times. So that's why they put a comment in front, right, of capacitor voltage. So because this round they want to run for inductor current, you need to run 2 rounds. 1 round for inductor and then another round for capacitor. And you get it. So then before we go into the software, so there are a few more things. So first thing is the .dc statement. You can find that you have .dc statement and the .print statement here. Why we need to have .print statement? Why you need to have the .print statement? So if you, without the print statement, like your Lab1 just now, they will print for you all your not voltages. But this round, we are not interested in the not voltages, right? We are interested in the voltage between, voltage between these 2, 3, right? So do you want to know what is V1, V4, V5? No need, right? We want to know between AB here. So we just want to know the voltage and current here. So that's why we can use print DC. You can see print DC IL1 inductor current, or print DC VC1 capacitor voltage. Can you get what I mean? So that's why the dot print statement is actually to find for the specific values. So by default, they will print the node voltage. Then the syntax is dot print type, then the output variables. Okay. Then this is the dot print statement. Then okay, dot DC statement. So dot DC statement is here because the dot DC statement is needed by the dot print statement. Now you want dot print statement, but dot print statement cannot work alone. You need to have the dot DC statement. So actual function of this dot DC statement is actually to step the value, so to increase the voltage or current in a constant rate. So for example, you want to have the 0, then 1, 10 watt, then 20 watt, 30 watt, like that. Understand? A series of a range of values, and we use dot DC statement. Okay, but this one we are not using it for this real function. We are using it because the dot print statement need the dot DC statement. So that's why we only sweep it for one time. Dot DC V1 75 75 1. This one 75 75 1. So if you ask me, we have two sources here, right? I don't want to have the 75. I want to put 25. Can or not? Can also. Okay, we can test it later. Do you have any question? If you don't have any questions, then I will ask you to do your work now. Open the software and then run this. Okay, run this. Yes, the asterisk sign means comment. So you go to File, New. So you need to go to File, New text file, and then type this. Okay, I give you 5 minutes. I think can settle. Okay, how to write this type of coding, you know already, right? YB1 10 V2 556. So again, it's because of the numbering. Positive terminal link to 5, negative terminal link to 6. So that's why V2 5 6 DC 25. DC 25. Anyone have any question? Let me know if you already done. Yeah. Need to do twice and manually calculate. What do you mean by need to do twice? Manually calculate is actually we want to know our simulation. So is it match with our theoretical calculation? Or L1 is yes, yes. You need to run it one time for example here I comment out the L1, right? So I run here, then I will have the capacitor voltage, so which is our Thevenin voltage 1.25 E01 means times 10 to the power 1, so means it is 12.5. Then I need to run one more round. I comment C1 and comment L1 and comment VC1, then I uncomment the current. So I run it again to get my inductor current. Is it what you want to ask me? After typing must save first. Yes, yes, you need to save first. Every time you need to save first. Even if you are not saving, then they will pop out and then ask you to save actually. They will ask you to save. Have you done any problem? Okay, done. Any problem? Okay, how many of you done? Anyone have any problem? So if you've done like that, let's us do some testing. Yeah. So for example, if I comment dot PC segments, right? Then I run. So view output file. Can you see? They will show you not 1, not 2, not 3, not 4, not 5, and not 6, all the not voltages. So your dot print statement cannot function. So that's why you need to have the dot DC statement here. And another thing that I would like to test is this one. How about 0 to 575 every 5? And view output file. So this is the actual functions of the dot DC statement. 0 volt, 5 volt. When V1 is 5 volt, what is the value? 10, 15, 20, 25, 30, 35 until 75. It gives you a range of values. Do you get what I mean? So this is the real functions of this dot DC statement. Just that we need it now. It is because without the dot DC statement, the dot print statements can't function. Can understand or not? So just to show you. So that's why this one we only say 75, 75 one time. We only need to switch one time because can you understand? Because we only interested in the dot print result. So you need to run one time. One you get the voltage for capacitor, another one you get the current for inductor. So unfortunately for the RTH, right, you can't do it. You need to use a voltage divided by the current from the simulated results, and then use a formula, Ohm's law, in order to calculate the RTH. Are you okay? Anyone can't settle experiment 2? Do you need more time for experiment 2? We only a few students earning less than half the class 61. Are the rest of you, are you okay? Okay, good. No problem, no question. It's very easy, right? So I think I give you a break. I mean, 5 minutes like that. Okay, we will come back around 3:20, 3:25 like that. Okay, I give you a break for 5 minutes. Then we will go into our last experiment for today. So we do experiment 3. After experiment 3, we'll end the lab and of course we can dismiss earlier. After experiment 3, then we will dismiss. If we experiment 3 we can end earlier, then why we need to drag the time? Or you don't want to break 5 minutes, is it? Break lah. Okay, I give you to drink a cup of water or what? Okay, then for those who haven't settled experiment 2, you can settle now.